So I organized this study guide based on Chapter 9, the topics for Chapter 9, which are acid and base naming, types of chemical reactions, aqueous solutions and solubility, complete and anionic equations. Then Chapter 10, it's only mole conversions and empirical molecular formula and percent composition. And Chapter 11 is all stoichiometry, including limiting and excess reactant. I'm going to reteach that real quick. And then also percent yield, okay, with little descriptions for each one with a bunch of practice problems at the end. And then after I'm done with that, which hopefully, I think I'll be able to get through all of that in this session. And yeah, once I'm done with that, I'll airdrop you guys this document and then I'll tell you exactly what to write on the cheat sheet, okay? So, we'll start off with acid and base naming. So we kind of briefly went over this in class when we were doing the Jeopardy game. For some classes, I already went over this, but we'll go over it again. So on your exam, there are 5 questions on acid and base naming. There are 18 questions on reactions, solubility, aqueous solutions, and complete and net ionic equations. There are 2 mole conversion problems, from grams to moles to particles. 1 question on percent comp, 1 question on empirical formula, 1 question on molecular formula, and there's 8 questions on limiting and excess reactant and percent yield. Okay, so we'll start off with acid naming. So remember, there are 2 types of acids that you should be familiar with: binary and oxyacids. Okay, both of these definitions are on the exam. So I will ask you literally in the way that I did on the Jeopardy. An acid that has hydrogen and only one other element is a binary acid. Okay, an acid that contains hydrogen and an oxyanion is an oxyacid. And it's a fill in the blank, but it's multiple choice fill in the blank. Okay, so those are 2 questions off the bat from the exam. Again, binary acids contain hydrogen and one other element, while oxyacids contain hydrogen and an oxyanion. Now, what is an oxyanion, you might ask? They are negatively charged polyatomics that have oxygen in the formula. Most of your polyatomics are considered oxyanions. Okay, so SO4, 2 minus, PO4, 3 minus, NO2, NO3, ClO3. These are all oxyanions because they're negatively charged ions containing oxygen. So you mix those oxyanions together with the hydrogen and you get an oxyacid. Okay, all acids contain hydrogen in front of the compound. It will always start with H. So every time you see H in the beginning, you know it's an acid, right? Okay. So the naming process for both of these types of acids are different, and the rules, I will write them for you below. So I'm going to write everything in a different color so that you know what's written by me and what's written in class. I mean, what's already in the doc and what's written in class. I'll write it in pink. All right. So let's talk about binary acids first. Some rules, okay? To name a binary acid, it must start with hydro, the first word. So I'm going to put that. First word must start with hydro. Must start with hydro and end in ic. Okay? The middle part of that word is the stem of the second element. So stem of second element is middle part of the word, if that makes any sense. It does? So, the stem of the second element, I should say. The stem. You'll see what I mean when I give you examples. So, for example, if I give you HF, okay, we said the first word must start with what? Hydro. And it ends in ic. So the middle part of that word, it should be the stem of the second element. Does that make sense? Fluorine is the name of the element. Without the ending "ine," what is it? Fluor. That is the stem. So the name of this acid is hydrofluoric acid. Okay, and of course the second word is just acid. That makes sense? Okay, if I gave you like this, H2SE. Again, for binary, the first word must start with hydro and end in ic. The stem of the second element. Who's my second element here? Selenium. And then what's the ending of selenium? Ium, right? Selenium. So exactly, the middle part, or the stem of that will go in the middle part. So hydroselenic acid. Does that make sense? Okay, so what would this one be? Good. Hydroiodic acid. Okay, so everyone's good with this one? Everyone's cool with binary acids. Okay, for oxyacids, you got to be very familiar with your polyatomics to do that one. So we'll go over here. Rules. Okay, for oxyacids. Must pay attention to the, I'm going to say PA means polyatomic. Polyatomic in the formula. Okay? If the PA ending, polyatomic ending, is with ite, your acid will end in OUS. If your polyatomic ending is ending in ate, your ending for the acid is ic. Does that make sense? So, we'll do a few examples. Okay. So, all of these are oxyacids. How can I know? How can I tell? They all have oxygen and they all have polyatomics. Beautiful. Okay? Now, I need to identify the polyatomic in each acid. So for the first one right here, which polyatomic do you see? Right, so ClO3 is chlorate. Okay, what does chlorate end in? 8. So instead of 8, what am I replacing it with? Ic. Okay, ic. Chloric, and the second word is always just acid. Okay? Next, who's my polyatomic? Carbonate. And what does carbonate end in? Right? Okay. So then what should my acid end in? Ic. So carbonic acid. Does that make sense? So let me I'm going to make the scribbles a lot less defined so you can know what I'm trying to X out. Okay. And then H2SO3. What's my polyatomic? Sulfite. Because sulfate is SO4. So now this one ends with ite. So instead of ite, I'm putting? Exactly. So no ite. I'm putting OUS, right? So it's sulfus. Not really sulfus, though. We don't write sulfus. We write sulfurous for sulfur. And for phosphorus, we don't put phosphus, we put phosphorus with acid after. Okay, and the last one, HNO3. Who's the polyatomic? Nitrate. Nitrate. So then I would do what? Nitrate is the polyatomic. It ends in 8, exactly. So then I will not put 8 as the ending. It will be OUS or IC or IC. Right. So ic is the ending, therefore nitric acid is the name of this acid. Does that make sense how I got these? Yeah. Okay. Now, what if I were to give you, I should have left more space. What if I were to give you the names and I were to ask for the formulas? So for example, if I were to give you and I ask for the name. Sorry. I mean, whatever. We'll do it already. I meant to give you the opposite. What's a polyatomic here? ClO. Do you know the name of that? Hypochlorite. What does it end in? Ite. So we don't put ite. What do we put? Us. Yes. So then that would be hypochlorous acid. Do you see that? Okay, how about if I gave you like this? Whoa. And I were to ask you to write the formula. How would you do that? Well, say it again. So you know that it's an acid, so it has to have H, right? Perchloric, there's an ic ending. What does that tell you about the polyatomic? It ends with H, so this is perchlorate. You know that perchlorate is ClO4, correct? But remember, you have to cross the charges. H is plus, ClO4 is minus, so this will give us HClO4. What if I were to give you this one? Did we? Can't think of any acids. Whatever, we'll do it again, the opposite, just so you can know like the process. So I'm giving you words, I'm not giving you formulas. You know sulfur is going to be in the formula. What is the ending of this acid? Us. So the polyatomic must end in ite. But you know sulfite doesn't exist. Oh yeah, it does. Sulfite is a polyatomic, yes? So sulfite is a formula of SO3 2 minus. And you know that all acids are bonded to what? So when you cross those charges, you end up with H2SO3. Good? Everyone go with the acids? So I'm going to put a little squiggly line so you know that this is separated. Okay. Good? Okay. Bases are a lot simpler. It's just one way to name one type of base, and it's just like naming ionic compounds. Okay, you say the name of the cation, name of the anion. In order for you to be a base, what do you need?
Oh,
hydroxide. Good. Okay? The naming rules for bases are very simple. Name the cation like normal. Then name the anion. That's literally it. If you need to write the formula, what should you make sure you do with the charges? Good. Make sure you cross the charges. Okay? So let's do an example. Let's say I give you MgOH2, and I also give you potassium hydroxide. I also give you calcium hydroxide. And I also give you SrOH2. Or actually, I'll say AlOH3. Here's 4 examples. So if I give you the formula, what do I expect? The name. Well, what's the name of my cation here? Magnesium. And what's the name of my anion here? That's it. Very simple. Oh, actually, I'm going to change this. Okay. Potassium hydroxide. Now I'm giving you the words. So how do I write the formula? Right, just cross the charges. We know potassium is K. What's the charge of potassium? I know hydroxide is OH minus. When I cross that, I get KOH. That's my formula. Okay, with calcium hydroxide, same thing. I know calcium. What's the symbol for calcium? Ca, and what's the charge? from the periodic table. And I know again that hydroxide is what? OH minus. And when I cross it, how many OHs should I have? Yeah, how many OHs should I have? Is that right? I gotta put parentheses if I have more than one polyatomic. And how many CAs should I have? 1. So CaOH2 is correct. CaOH2. Does that make sense how I did that? Okay. How about this guy? FeOH3. Right, just say the name, iron. And what's the second part? Oh, you're missing something. Nice, the Roman numerals. Why do I have Roman numerals here? Transition. And what do I put in those Roman numerals? The charge, which is 3. How'd you know it was 3? Uncross. The 3 belongs to iron. I put 3 in Roman numerals. Iron 3 hydroxide. Am I going too fast? Everyone's okay? Nice. Any questions so far? Okay. So now we're moving on to types of chemical reactions. There are 5 types of chemical reactions. On this exam, I'm going to ask you to predict products. I'm going to ask you to identify reactions, and I'm going to ask you to write complete and net ionics. So it's very important that you can look at a reaction, know what type it is, and then give reactants and also write the products. So first type of reaction you should be familiar with are synthesis reactions. They contain only 2 reactants, and those reactants are elements. To predict the products, what do you have to do? Just cross the charges. That's it. Very simple. You automatically see 2 plain elements. What do you think of? Synthesis. Again, you see 2 plain elements as reactants. What do you think of? Synthesis. How many products will I have? 1. All I do is crisscross those charges. Okay? So, for example, aluminum and oxygen. Aluminum has what charge? 3 plus. Oxygen has what charge? 2 minus. I don't care about the number that's there. When I cross those charges, how many ALs should I have? 2. Okay, and how many O's should I have? 3. There's my product. Obviously, I have to balance it, correct? Okay. So I have 2 O's on one side, 3 O's on the other. Any idea how I can balance that? Right. So to make this a balanced equation, I put a 3 here to make this 6. But I put a 2 here to make the other O 6. But how many aluminums do I have now? So I have to put 4 here to make that balanced. Okay, how about Na and S? Right, I'm crossing the charges, synthesis. Na is plus. Any idea what S's charge is? 2 minus. Na will receive how many? 2. And S will receive how many? 1. But do I write the 1? No. My final answer is Na, what? 2S. And is it balanced? How do I balance it? Just a 2 in front of Na and it's balanced. How about K and Cl? K is what charge? And Cl? Minus. When I cross them, KCl. Okay, is it balanced? How do I balance it? Add a 2 in front of KCl to balance the Cl's. But now what's messed up? Yeah, the K has 2 now, so I have to put a 2 over there. Good? Anyone have any questions on synthesis reactions? Okay. Combustion. Okay, there's 2 types of combustion. So I put the formulas of each reaction with the arrow next to the name. So synthesis was A plus B gives me AB. A plus B gives me AB. Okay? Combustion, there's 2 ways. CXHY. What does that mean, do you think? Hydrocarbon. Good. This is something we like to call a hydrocarbon. What makes something a hydrocarbon? Right. It has to be a compound with... Right. With hydrogen and carbon. Sometimes, who? Oxygen. Sometimes oxygen can be there. He's allowed. So, when I have a hydrocarbon reacting with O2, this is combustion, right? What makes something combustion? O2 as a reactant. But when I happen to have a hydrocarbon reacting with that O2, I will get the same products every time. H2O and CO2. Or I can have a standard combustion where it's just a normal element and he reacts with O2. And what do? I just combine them by doing what? Crossing charges. So X and Y just tell me how much of each there are. Say it again. Same as synthesis. Exactly. This one's same as synthesis. So synthesis and combustion are the only reactions that you can have at the same time. Just those two. Okay? So again, combustion does what? It contains who? O2 as a reactant. There are two types of combustions that can be seen. O2 reacting with a hydrocarbon, like over here, or O2 reacting with another element, like over here. Okay? If O2 reacts with the hydrocarbon, what will my products always be again? H2O and CO2. Perfect. Okay, so let's predict. Here I have C4H10 plus O2. What are my products? H2O and CO2. Does it matter the order? No. Is this a balanced reaction? No. It's not. Who do you think I can balance first? Yeah, C. How many C's do I have? 4. So where would I put a 4 to balance? Right here, right? Okay, now what? 4 plus 2, sorry, 4 times 2, 8 plus 9 oxygens. We'll worry about that later because I can't fix that. How about my hydrogens? Can I fix my hydrogens? Yeah. How? Add a 5 in front of H2O. So then now I have 10 here and 10 there. But how many oxygens do I have? Sorry. Hello? Yes, I'm tutoring now. All right, love you. Bye. Okay? 13. Now but hold on. How many do I have on the right? 13? On the left. I need to get O2 to become 13. Oh, this is one of the weird ones where you have to double up the reaction to balance it. Okay, I'm not going to give you any like crazy ones. There's 5 here and there's 8 here of oxygen. Yeah, 13. So, yeah, this is the one where you had to double all of the coefficients. So change 5 to 10. Double it. Change 4 to 8. Now how many oxygens do I have? 20. So that's an even number. So then what would I do on the other side to make it 26? 13. And then how can I fix the carbon and the hydrogen? C4H. Yeah, we do. Because there's 4 C's here, but there's 8 C's here. Yes, 2. Okay, there we go. That was a weird one. You're not going to get a weird one like that, but that's just balancing for this reaction. Okay, again, how do you know it's combustion? Because it's an O2 as a reactant. How do you know that it needs H2O and CO2 as products? Because it's with a hydrocarbon as a reactant. Okay, for this one, what kind of reaction is this one also? Synthesis and combustion, because I have O2, but I also have 2 elements. When I have those 2 plain elements, how can I get a product? Cross the charges. Mg is 2 plus, O is 2 minus. What is the formula? Right, because the 2's do what? They just cancel out. So MgO is the final answer. Is it balanced? 2 here? Like that? Good. Any questions on synthesis or combustion so far? Okay. Decomposition is where I'm going to get you, huh? There are 4 types of decomposition. Keep in mind, in order for me to be decomposition, what has to happen? 1 compound as my reactant. Yes? There are 4 types of decomposition. Binary, metal hydroxide, metal carbonate, metal chlorate. Okay? In a binary decomposition, what happens? A compound containing only 2 elements break down into those elements. Simple. If I have CaO over here, what are the only 2 things that it can break down into? Calcium and oxygen. Can I throw in a random iron here because I feel like it? No, that breaks the rule of what? Law of conservation of mass, right? If I start with something, I have to end with something. Okay, so what's wrong with this though? Yes, so all of my Brinkelhoff elements must get 2. So I'll write that here. Brinkelhoff. These 7 guys must have 2 attached to them when they're sitting by themselves. Is O sitting by himself here? So he receives a 2. Is this a balanced reaction? No, so how would I fix it? Perfect. You're with me. Am I going too fast? No? Tell me if I'm going too fast. Okay, Al2S3. Again, binary decomposition. 2 elements. What are the only things it can break down into? Al and S. Do I have any, thank you. Any Brinkelhoff here? Any diatomics here? No. So I leave it, but is it balanced? How can I balance it? 2 in front of Al, 3 in front of S. Okay, so that one's easy. You just break it up into the elements that it makes it up. That's binary. Okay? Next. Metal hydroxide decompositions. What's a metal hydroxide? A metal with hydroxide. Hey, you see that? You see how I highlighted green for metals? And then what did I highlight for hydroxide? Red. You see that? Okay. So, metal hydroxides always break down into what? Metal oxides and water. So for LiOH, I need a metal oxide and I need water. Well, who's my metal for LiOH? Li. Okay, and what's the charge of Li? Plus. And metal oxide, what do you think a metal oxide is? A metal with oxygen, which is 2 minus. So what's the formula? And the second product must be H2O. Same thing for the other guy, SrOH2. Again, I need a what for my product? A what and a what? Metal oxide plus water. Who's the metal in this one? Right? What's its charge? Good. And my oxide is just oxygen, O2 minus. And what is that? Right. Plus H2O is my product. And remember, all of these reactions must get states of matter and must be balanced. Yes, I will give you the solubility chart and I will give you the periodic table, correct. And I will give you the activity series. Is this one balanced? Yes, it is. It is.
Which one? Oh, yeah.
Good? 2 O's, 2 H's, 1 SR. You're with me? Okay, metal carbonate. What's a metal carbonate? A metal with carbonate. And that decomposes always into what? Metal, same thing as above, but instead of H2O, CO2. All right, so MgCO3. How can I make that? Metal oxide and CO2. Okay, so my metal oxide here is Mg, which is 2 plus, and oxide O2 minus, like you guys said, MgO, right? Because the 2's cancel out. And what was the second product all the time? CO2. And this one's balanced? Yes. Okay, how about the next one? Na2CO3. Again, what are the 2 products? Metal oxide and CO2. Who's the metal here? Na what? Plus. And CO3. Sorry. And O2 minus. She goes, what are you doing? Metal oxide. So what's the formula? Plus, the second product's always CO2. So this is just memorization. So I would definitely, have a section. Well, I'll go over what you have on the cheat sheet. You'll have everything you need to know. Okay? And then last but not least, type of decomposition, we have what? Metal chlorate. So metal chlorates break down into and oxygen. So not metal oxide this time, metal chloride. Who's chloride, do you think? Chlorine. So over here, who's my metal? And what's the charge? And chlorine? Cl minus. So Right, KCl, metal chloride and oxygen, right? And it has to have O2. Why? Because it's diatom. Okay, how about the next one? Chloride and oxygen. BaClO3, 2, breaks down into metal chloride. So Ba, 2 plus with, which gives me with O2. Perfect. Are both of these balanced? The first one's not. Both of them are not. Wait. How do I balance this one, the KClO1? This one. Look at my O's. Right. I have 3 and 2. So I should make this how many? Right, by putting A. Perfect. And then make this 6 by putting A. Good. But what does this 2 do to my K and Cl? Doubles it. So then on this guy I have to put a 2. You're with me? Is that too fast? Am I going okay? Tell me if I'm going too fast. Okay, BaClO3, I want to balance it. I have how many chlorines? 2 over here and 2 over here. How many oxygens? 6. But how many over here? 2. So how should I make that 6? Perfect. Is it balanced? Yes. Awesome. I know. We're almost there. Once this exam's over, we're doing new things. I think so. Very simple. They're like plug-in equations. Like here's an equation. P1 V1 equals P2 V2, and I give you P, V, V, P, and then you have to find one of them. Like it's just plug-in equations. No, that's what you're learning for chapter 12. It's plug-in equations. Like P means pressure, V means volume. So I'll give you 2 pressures and a volume, then you have to find the other volume. You know what I'm saying? Yes, we are. Ideal gas laws will be in that chapter. Okay, so now we're on single replacement. So far, so good, right? Yeah. Okay. I'm going to tell you all the things you should put on your sheet later. And I'm actually going to make the sheet here. We'll make it together. Okay, ready? So single replacement reactions will always have one element and one compound as reactants. There are 3 types that we can get. A metal replacing a metal replacing hydrogen in water acid, and a non-metal replacing a non-metal. You need, what is this called? Activity series to solve for these. Okay? So, first one, metal replacing a metal. Remember, how do you know which one you're going to be doing? Look at the lonely guy. The lonely guy will tell you. This iron is what? What is he? Yeah, what kind of element is he? He's a metal. He has 2 options. He can replace another metal, or he can replace... Is there any hydrogens in this formulas? No. Here? No hydrogens. So the only option is he's replacing another metal, correct? Where's the other metal in this one? Cobalt. So metal replacing metal. Now, can iron kick out cobalt? Let's take a look. Can iron kick out cobalt? Yes, because he's higher on the activity series. So they're going to just swap places. So Fe is now with who?
Wait, let's say Fe's. You have to look at whatever the one is alone.
Yeah, the one alone has to be higher.
Okay.
Yes. Okay, so Fe wants to replace CO. Of course. Yes, Fe wants to replace CO. Is he allowed according to our activity series? Yes. So who's going to be by himself now? These 2 switch. Right, so CO is by himself.
Do we have to write the charge?
No, you cross them. So CO is by himself. Like here? This is given to you, this part.
So like when we write our reaction,
You cross the charges. There's
put CO2.
2? I see what you mean. No, you don't. Okay, so CO is by himself, correct? Fe, CO, they're switching places. CO is by himself. Fe is now with who? Right, but I gotta cross the. I can't just put them together, right? Fe is what charge according to my Roman numeral? According to my Roman numeral. Okay, and then I know NO3 is what? What is the charge? Oh, sorry, what is the formula? And again, all of this needs to be what? Balanced with states of matter. Okay? For time, with the single replacements, I won't balance and put states of matter. We'll just move on. Yeah.
On the exam, all the balancing and states of matter are already going to be in the answer choice, right?
Right. All the states of matter will. No, sorry. There's no states of matter, actually. The balancing, I'll have one balance, one not balance. Yes. Multiple choice? Except for one question. Where I give you, like, a bunch of compounds, and you have to put solid, liquid, gas, aqueous. Yes.
Will you have some that are balanced like wrong and then one is balanced right?
Yes.
Bro, you so weird.
She probably had a states of matter.
No, I didn't put wrong states of matter. That's doing too much. Okay. For the next one. Who wants to kick out who, guys, for this one right here? Wants to kick out zinc because he's a metal and he's kicking out another metal. Can chromium kick out zinc? Why? He's not higher. So then what do? No reaction. There are some like this on the exams. You have to be careful. I'm going to put the actual reaction and I'm going to put no reaction. Charts. Yes, of course. Okay? B. Metal. That's genius. That's genius. She said, is it wrong if I put the polyatomic list on my cheat sheet? No, it's not. You can do that.
Wait, you're not giving us
For polyatomics? Since when? Nice. Okay. Ready for B? Ready for B? Metal. Guys. Ready? Metal replacing hydrogen in either water or an acid. Obviously, there's only one formula for water. What is it? H2O. Anything that has hydrogen and is not H2O is an acid. Okay? So I want to see, can this metal replace this hydrogen guy? So I got to go take a look over here. Can rubidium, here he is, replace hydrogen? Absolutely, right? He's way higher on the list. So what's going to happen? H is going to be by himself. So I put H, but not H. I put H2. And RB is going to be with O, but not really O. Remember how water is made? H plus and OH minus. That's how you do water. Right? HOH. Remember that? HOH. So if RB is replacing the H, he's just replacing this. Right? Does that make sense, what I just said? So I'm going to put it here. H plus, OH minus. The H plus is what's getting replaced. So RB is actually with who? OH minus. So what's the formula? Right, because RB is a plus one charge. OH is a minus one, and then it's RBOH. Okay, how about Ba and H2SO4? Can barium replace hydrogen? Yes. Okay, so who is he gonna replace? Hydrogen, obviously. Who's by himself now? Hydrogen, but he's H2. And Ba is now with? Ba is what charge? SO4 is what charge? What's the formula? There you go. Good? Okay. Last but not least, a non-metal replacing a non-metal. So who wants to replace who for number one right here? Fluorine wants to replace bromine. Can fluorine replace bromine? Yes. So they're going to do what? Switch places. So F is now with K. What is K's charge? What is F's charge? Minus. What's the formula? KF. And who's by himself? Bromine. And what do I put? 2. Why? Because it's Brinkhoff. Okay? Next, who wants to replace who over here? Wants to replace? Can iodine replace chlorine? So what? No reaction. Good? Okay, ready? And last but not least, our double replacement reactions. We're almost done with chapter 9. I know. What time is it? Wow, that's not. We're doing really good, I think. Okay. Yeah, I think we're doing good. Bye. Have a good day. All right, so number 5, double replacement contains 2 ionic compounds as my reactants, and I get how many products in return? 2. In order for me to predict the products, who swaps? The anions. And you have to do what after you swap them? Recross the charges to form the new compound. Okay, so this is in pieces. Recross. So remember, the first part of the formula is always the, and the second part is always anion. Okay, so the anions are the ones who end up switching places, correct? The cats stay in the same place. So for this one, who is my cation? Al and sodium. They stay the same. Who are my anions? SO4 and OH. So they are going to switch places. So now OH is going to be with who? Aluminum. What is aluminum's charge? And what is OH charge? When you cross it? Good. Okay, that's my first product. And then again, so we just switched these two. OH was with Al. Now who's SO4 with? Na. What's Na's charge? And what was it? SO4? SO4 is 2 minus. Good. And what's the formula? Na2SO4. Is it balanced? How can I balance it? Look at my ALs. How many ALs? 2 ALs, and how many here? So how can I make that the same? How many OHs do I have now? 3 times 2 is 6. So how many OHs should I have here? So I put a 6. Yeah, and then I have 6 NAs, but I should have 6 NAs here, so I put a 3, and then now it's all balanced, right? Okay. Good? The second one. Who's switching places in the second one? NO3 and S. Okay, they're going to switch. So, who is with Fe now? NO3. Well, do I know Fe's charge? Right. If I uncross the charges, I can get Fe's charge. What is Fe's charge? 3 plus. How do I know it's plus? And he's the first one written, right? So 3 plus. And who is Fe with now? NO3 what? What's the formula? Good. Plus, who is S with? Barium. Okay, so let me just... Remember, NO3 and S changing places. You're with me? So who is BA with now? S. BA is what charge? S. 2 minus. What's my formula? Is it balanced? Nope. How can I balance my FEs? 2 FEs here. How many here? 1. So I should have to put a 2. How many NO3s now? 6. So how many NO3s do I have here? I have 2, but I need 6. So how can I make it 6? How many BAs? So what should I do? 3 over here? Is my S's balanced? Okay, there you go. Okay, and then can you tell me what you get for the last one? You do that one real quick. Just tell me what you get.
Are we only doing the thing, or do you want us to balance as well?
Say it again. Yeah, balance 2.
ClO2 is what, charge 3?
Minus 1.
C is one of the exceptions. Copper.
Copper. Exceptions to what?
Exceptions are Ag, zinc, and cadmium.
Yes, let me put that on the side.
List of the
So remember, there are 3 transition metals that don't use Roman numerals. Zinc, cadmium, and silver.
I forgot how to use
And what's the
CrO4 has a 2 minus charge.
Can we go back to it?
Yes. Wait.
what's copper's charge.
You tell me.
Oh, it's 2.
Mm-mm.
It's not 2.
So chromate has a 2 minus charge. Cu, if I give that to chromate, to copper, I get 2, right? Like this. But how many chromates do I have? How many Cr4s do I have? 1. So that means I have 1 plus charge on copper. Does that make sense?
Oh, wait, that's ClO2.
Right? Did everyone see that? So this is a charge of copper. That's a charge of chromate.
I actually have to write that in something.
Tell me when you're ready.
I'm ready.
Yes.
I think so.
Do you want me to go back to the thing?
Yes.
Sorry.
See, how many questions?
40.
How many?
Hmm?
We not serious.
56, I think.
Yo, what am I going through?
The last one. This one is 40, I said. Do you got an answer for me?
Yes.
Yes? Okay. What did you get? Tell me.
I don't even know what I'm writing.
Cu, parentheses, ClO2, parentheses, 4. Okay.
How did you get this?
No.
No. Isn't it? Is C not plus 1?
All right, look at this. What charge is copper here? When you uncross the charge, remember the 4 belongs to O. There are 4 oxygens in chromate. There are not 4 chromates. If there were 4 chromates, it would be like this. How many chromates are there? 1. So you uncross that number. So 1 is the charge for copper, right? Okay. And the charge for chromate is 2 minus, correct? Okay, how about the charge for K and ClO2? K is plus, negative. Now, to get my products, who am I changing places? Okay, so then what happens? This guy, he moves here, and this guy moves here. So then when I recross those charges, I get good and K2. Beautiful. Yes, that one is correct. Okay, does that make sense? And did you have to balance it? Okay, let me just real quick. Okay, what did you get for coefficient starting from the beginning? So 1, 2, 2, 1, like that? Yeah? Everyone got that as their coefficients? Okay, good. We're good? Okay. All right, aqueous and solubility. This definition right here is right on the exam. Solubility is the ability of a solute to dissolve in a solvent to form a solution.
I'm gonna have this in the exam.
This chart will be on the exam, yes. You guys asked me this 100 times. Okay? Aqueous solutions are solutions that contain a solute dissolved in a solvent, where water is the solvent. Okay? Now, not every time will our aqueous solutions contain dissolved particles. What does that mean? You're listening? It's right here. Okay, guys, look at this. If I have a cup, hold on. If I have a cup of water, right? If I have a cup of water, and I put in some NaCl, is that aqueous or no? Yes. I put it inside. What happens to it? Into Na plus and Cl minus. I can break up the aqueous compound into its ions according to the complete ionic reaction, right? But if I take some PbSO4, for example, is he aqueous? No, he's not. So if I put him inside, he will not break apart into ions like this. He will just sit at the very bottom as a pile of clump because he can't be dissolved. Does that make sense? So what this is saying is that in an aqueous solution, I won't always have only dissolved particles. I can have those dissolved particles, but also have some solids in there that are not able to be dissolved, which we call precipitates, sitting at the bottom of the container. Okay, so this whole thing is called an aqueous solution, even though I have solid in there. Does that make sense? Okay. Anyone have questions on how to read the chart? So I want to tell you a secret. All of the first group, what are they called, those first group? Alkali metals. Read them to me from the top. Even though H is not, but it counts here. H, Li, Na, K, Rb, Cs, Fr. All of those elements, anytime you see them in a compound, automatically soluble. Do you see anyone from here? NaNO3, automatically soluble. So I put KCl. K is in there, right? Automatically soluble. Okay?
The whole first column is?
Mm-hmm. Ammonium and NO3 are also the same thing.
Can you write
I mean, I don't have to write it down. It's just like a trick. But everything is in the chart.
Also the chart, so we don't have to write.
The chart says what I'm just saying.
Okay.
Yes. I'm just giving you, like, tricks.
How are you gonna give these many to each one of us? If you
For NH4.
I'm going to give it to... Guys, I've given this to you before, have I not?
Yeah.
I've given you a periodic table before, yes? Do I put it on the board? Each one gets their own periodic table. Each one gets their own thing. It's the same exact stuff. Okay.
Was the H and NH4 make it aqueous?
It is already aqueous, NH4 2CO3. So guys, look at this one. NH4CO3. Do you see any of them here? Where? I see them in both places. Wait a minute. They're in both places. One says soluble, one says insoluble. Huh. Guys, they'll be the same exact thing if you were to work it out. What does it say about NH4? No exceptions. I'm done. I don't even have to look at I don't care about that. I want the one with the least amount of reading as possible. Do you understand that? This one says automatically soluble. So I don't care about reading the other part. I put soluble, which is aqueous. O2 over here. What is O2?
Gas.
A gas. Brinkelhoff guys are gases. Except for iodine. And bromine. Iodine's a solid, bromine's a liquid. How about MgO? This is a metal oxide. Remember what it says about metal oxides? Right. Well, do you see Mg or O in the table? No. Solid. How about Ti? What's that? Titanium. What's titanium? Solid. He's a metal. Okay. And can you tell me what AgBr is looking at this table? AgBr.
It's solid.
Br is what? So it's aqueous. Except if bonded to, is that a part of the exceptions? Therefore, it changes from soluble to making AgBr a solid. How about BaSO4? Do you see Ba or SO4 over here? Where?
Someone needs to click
Right there. Thank you. SO4 is what, guys?
solid.
So therefore, but hold on, I said BaSO4. There's an exception. So therefore, it's solid insoluble. Does that make sense? Same thing goes for this table. It's the opposite. So this part is solid, but if it's over here, it's aqueous. Good. Okay? All right. Completed net ionic equations. Make sure to balance the reaction first before you break it up. Okay? For complete ionic equations, it shows us all soluble ionic compounds in a reaction written in ion form. In order for me to be considered soluble, I have to have an AQ written right next to me. Do you agree? In order for me to be soluble, I have to have AQ written next to me. So I can only break down my aqueous compounds as their ion forms. If they don't say aqueous next to it, if it says solid, liquid, or gas, can I break it up? No, it stays the exact same. Every single complete ionic equation must have state of matter of each ion, charge of each ion, and coefficient in front of each ion, showing me how many there are. Okay, make sure you balance the reaction first before doing that. Complete ionic equations don't always contain aqueous solutions. We said this. They can also have precipitates, liquids, and gases in them. A net ionic is the exact same thing, except they don't show any spectator ions. Spectator ions are ions that show up on both sides of the reaction and do not participate in the reaction and remain unchanged. This is also a definition straight from the exam question. Okay? So here are the rules. Solids and liquids and gases cannot be separated into ions. All reactions should be balanced correctly before. You can only cancel spectators that are identical to each other. Okay, it says write the CIE and NIE for the reaction between cobalt 2 chlorate and aluminum hydroxide. So do you see how I'm only giving you the compound words, not even the compound formula? So let's do that. I need to write the reaction for this. Can you tell me the type of reaction that complete and net ionics are? Always. Always what? Double replacement. These are always going to be double replacement reactions. So I know I have a double replacement in my hands here. How do I start writing the formulas for these? I got to find the charges, and I got to find the symbols in the polyatomics. What's cobalt's symbol? Okay. CO2 plus. And chlorate is? Okay, and it's a reaction between him and who? Aluminum hydroxide, which is Al what? 3 plus with OH minus. So what's my first compound? What should I write my first compound? CO. When they cross, parentheses. Good. Reaction between him and Al. Beautiful. And we're making products. Okay, I need to remember my rules for double replacement. Who's switching? Anion. They're switching places. So, also, another way you can look at it, this is a compound, right? I have the front and I have the ending. Front, ending. So, if you look at it as like one whole sentence, my outsides are cobalt and hydroxide. Do you see that? So, I make this a compound. Then my insides are ClO3 and aluminum. I make this a compound. So you could do the insides together and the outsides together, if that helps you. But I just like to think, okay, the negative ones, swap them. So OH is now with who? And what's CO's charge? CO's 2 plus. Because I uncross this and I get 2 plus. And also, where else does it tell me? Right here, right? Okay. So OH is now with who again? CO. And I know that OH is what charge? So my first compound is what? Perfect. Plus, ClO3 is now with who? Huh? They're switching. Aluminum. Aluminum is what? 3 plus. And ClO3 is minus. So then my compound here is Al. Perfect. Do you see how I got that? No questions on that? Okay. Good. Yes, we have to balance our reaction. So let me just reformat this over here. Okay. All right. You tell me how to balance. What should I do? Minus on? Minus?
No, you remember, like, you just did it, actually.
Oh, yeah. Okay, good. Thank you. Okay, so I have 1 CO, 1 CO. I'm good. I have how many ClO3s? 2. How many ClO3s? 3. I got to make that what number then?
6.
So I got to put a 2 here to make it 6. But then how many aluminums do I have?
3.
How many aluminums do I have?
2.
So how many should I have on the other side?
2.
So I have 2 ALs here. So I should also have 2 ALs here. But how many OHs does it change? To 6. So how can I fix that?
3.
A 3 on this guy, because 3 times 2 gives me 6 OHs here. Then how many COs do I have? 3. So now I have to go over here and put a 3 here to fix that CO. You get what I'm saying? Okay. You know what I'm saying? You get me? Good. So this is my reaction. Here is my reaction. Okay? Before I even start writing out my completed net, I need something very important. States of matter. Good. Okay, my states of matter. So how can I find what my states of matter are? I gotta use the solubility chart. Okay, so let's do CO, ClO3. Do you see CO or ClO3 over here?
Yeah.
What does it say about him?
It's soluble.
And has no exception. So what should I put if he's soluble? AQ. Okay, 1 down. Next. AlOH3. Oh, no, it's not aqueous. This is a really bad problem to do. I'm going to pretend it's aqueous, okay? I'm just going to pretend it's aqueous. It's not. But with these kind of reactions, you should have 3 aqueous and 1 not. So having another solid in there messes me up. Pretend. Okay, I'm saying pretend. On the exam, you will have 3 aqueous, 1 solid. Okay, ClOH is a solid.
How do you know?
I remember.
Like,
Yes, you go to the table. CO, O or H. Do you see anyone there? I see OH. OH is what? Insoluble. Is CO an exception here? No. So it stays insoluble. Does that make sense? Good? Okay, and then AlClO3 is, go back to my chart, Al or ClO3. Do you see him here? Al or ClO3. And what is he?
No exceptions.
Soluble. Therefore, no exceptions. He's aqueous, correct? Okay. Good. You're with me? So this is my balanced chemical reaction. Okay, now I want to find my complete ionic equation. I'm going to, again, this is pretend. It's not actually aqueous, but for the sake of the problem, I made it aqueous. You get me? Okay. So now, if I want to write the complete ionic, I have to take every single aqueous compound and break it up into the ions that makes it up. How many ions are in there? 2. A cation and an anion. You're with me? Can I break up this guy over here? He's aqueous. So I will break him up into the cation and into the anion. Who's the cation again? CO. How many COs do I have? I got to put the 3 there. I don't put the 3 there. Okay? 3 COs. What is his charge? And what is his state of matter? Because he comes from an aqueous compound. That's the first part of this compound. What is the second ion part of this? So that was the cation. What's the anion? Good. Plus ClO3. How many ClO3s are there total? Right. 2 times 3 is 6. So I put a 6 in front. And what's the charge? And what's the state of matter? All of them will be aqueous if you're breaking them up. Yeah. Like 5. Okay, next. Can I break this up? Yes, right? It's aqueous, correct? So who's my cation I'm breaking up? How many ALs? 2 AL, and what's the charge? And what's the state of matter? Plus, how many OHs? Good, and what's the charge? Minus, and the state of matter is aqueous, good. Yields. Can I break up this guy over here? Why? Good, so I put 3COOH2, exactly the way I see him. I don't even touch him. Okay, plus, I can break them, right? Yes, AL is my first one. It's 2AL. There's 2 of them. Oh my gosh, 2 of them. 3 plus 6. Okay. Perfect, good. Okay, so now I have to take a look. This is my complete ionic.
Wait, Missy,
Yes.
why do you have to be
That's a charge of aluminum. You have to write the charges for all of the aqueous ions. Okay? So, to get my net ionic, I pretty much did all of the hard work. Now the easy part is canceling out, what do we call them? Spectator ions. And who are they? Both sides. So who do you see showing up on both sides of our complete? 6 ClO3 minus, 6 ClO3 minus. 2Al3 plus, 2Al3 plus. What's left over? Plus aqueous yields. So I just rewrite everything that I didn't cross out. You're with me? Yeah, does it make sense? The CO and OH make COH. Yes, but if I had like a random iron here, would it make sense? No. Always have one soluble. Almost done. We only should have one more. We should always have one, solid product. Everything else will be aqueous. Now that gives me a reason to tell you my shortcut. Okay, so let's take a look at the second one for a second. It says write the NIE. Well, I need the CIE to write the NIE, correct? But let's say I'm like, I don't have enough time. I have like 10 minutes left of the exam. I'm not even like done with this question. Let me see if I can figure out a shortcut. And I don't have to do this entire blue one, right? That's so long. You get what I'm saying? Here's a shortcut. First things first. What's wrong with this equation? There's two things wrong. Balanced and states of matter. Okay, can you take a look at this and tell me what I should balance? So look at my NAs. How many NAs? And how many here? So I should fix that by doing what? In front of this? How many NO3s now? Nope. 3, not 9. 9 oxygens. But there is 1 NO3 here. Does that make sense? If I had 3 NO3s, it would be parentheses 3. 3 times 3, 9 NO3s. But that's not the case. You're with me? Okay. So how many NO3s are here? 1. So I need 3 of them. So I put a 3. How many AGs now? How many are here? Is everything balanced? Okay. States of matter. Na3PO4. Na3PO4. Na is soluble. Are they exceptions? No. So what do I put? Aqueous. How about AgNO3? How about an AgNO3, guys? AgNO3. What is the state of matter? Aqueous. Okay, how about NaNO3? NaNO3. Aqueous. And how about Ag3PO4? Right. So PO4 is here. Is Ag an exception? No, and it's what? Insoluble. That's my solid right there. You're with me? Okay. I'm asking for the NIE. This is the short one right there. So to save me a lot of time, instead of having to write all of this out, I identify first. Who is my solid? So I'm going to make an arrow pointing to him. I know that he's the end. He's the end game, right? You're with me? AgNO3. No. AgPO4. S. Right? You're with me? Oh, thank you. Okay. You're with me. So again, my net ionic will always have the product solid at the end as my product. Now, what makes up this compound? Ag. Yes, but how many of them? And these I write as ions. 3 Ags plus aqueous plus PO4, 3 minus aqueous. This part will always be aqueous. Then they come together and they make something solid. Do you see how I did that? And you can do that on the exam to shorten, to save time. Does that make sense to everyone? No? Which part? Tell me. No. Tell me, really. That's what we're in tutoring for.
Can you do it again?
So remember, the goal of this question is to find this part right here. The short one. So to find the short one, traditionally, you'd have to do the whole blue one over here to do that, right? But we don't have time for that. I have things to do, right? We have things to do. This exam is 40 questions. You don't have that much time. So I'm going to skip the CIE and go straight to this one. Because if the question's only asking me for that, I don't care about this, right? So to save me time, I remember in a net ionic, I always have it pointing to the solid product. Well, in my black reaction here, which one was the solid product? So it's pointing to my solid product. I write that. Then I see, okay, what is my solid product made of? What is the cation? What is the anion here? Ag and PO4. How many Ags do I have? 3. How many PO4s? 1. And I have both of their charges written there. And this is the net ionic without me having to do the complete. The net will always equal the solid. Okay, so I'll write that for you. Net ionic equations will always equal the solid. Does that make sense? Okay. Now we're on chapter 10. There are 2 questions on the exam of chapter 10. So I'm gonna speed through this one. On mole conversions. Because don't forget, this is mole conversions, grams, moles, particles. Did you not just take a quiz on this?
That's not 11.
So I'm not. Chapter 10, mole conversions, grams, moles, and particles, 2 questions. You just took a quiz on this, yes? So I'm not giving you questions like this on the exam. Stoichiometry, you have a lot more. You have 12 total. There's 4 normal stoichiometry. There's 8 of the limiting excess reaction with stoichiometry in it.
Wait, what's the difference between stoichiometry and limiting?
You have to.
Stoichiometry is just using a reaction to go straight from something of one substance to something of another substance. Limiting and excess, you use the coefficients to see how much you need and the amount of grams to see how much you have and convert them to moles. I'm doing all of these examples now. Okay, and we have still 50 minutes left, so I'm good. Okay, and my thing's still recording? Thank God. So, imagine stop. I would just kill myself. No, I'm joking. Mole conversions. We're going to read this to me very carefully. You ready? So, mole conversions are what? Conversions? Same? Okay. No. Conversions between grams, moles, and particles of the what? Same substance. Stoichiometry is different in the sense that it's a conversion between 2 different substances. And you need a reaction for that. For these, you don't need a reaction. Does that make sense? Okay? These type of conversions do not use a chemical reaction and can be done by just using our known and our conversion factors. We have 2 conversion factors we use. Avogadro's number, which is what? And what's the unit? What are my representative particles? And atoms, what kind of substance? Molecules and formula units. Okay? And what's my other conversion factor? What's molar mass? Grams over mole, mole over gram, grams per mole. And where do you get the grams from? Perfect. And mole is always going to be 1 for these types of conversions. Sig figs do matter. These questions, I will actually have 1 correct answer, both correct. 1 is wrong sig figs, 1 is right sig figs. For example, I can give you the answer, let's say you get 11.33, and the right answer needs 3 sig figs. I will either say 11 or I will say 11.3. This one, sig figs do matter.
I have a question.
And then like random numbers.
So we should
55,
narrow it down
20.
to two then.
Uh-huh. The ones that are the same number,
Oh, this is easy.
then you have to make sure it's the right sig
She'll
figs.
work.
Well, I'm going to be honest with you. Do you think I'm going to sit here and check the work of 183 different exams? No.
Oh, come on.
Is it multiple choice? Will I penalize you for guessing? No. So you guessed every single work problem right, and there's no work, I can't penalize you for that because it's a multiple choice test. However, if it was a written test, obviously, it's different. Anyways, back. Don't get any funny ideas. You're still going to study and still going to do good, right? And not guess. Good. Oh, you can't give him a cheat sheet. I'm taking your cheat sheet. Oh, okay. So I'm going to give you a 0 on the exam you haven't even started yet. Anyways, I got to get moving. So, you ready? Okay. Now, I have 3 examples. How many grams are in 4.1 times 10 23rd molecules of NH3? How many substances do you see here? 1, NH3, and how many numbers? 1. So I know this is a classic conversion problem. Molecules are involved. My given is 4.1 times 10 to the 23rd molecules of NH3. And what is it asking for? Good. So then you need the map for these. Remember that map? What is the map? Yeah, or vice versa. It doesn't matter. What am I starting with for this? Yeah, molecules. And what is molecule? A particle. And where am I going? What am I asking for? Huh? Grams. But I have to go to moles first, right? But my end goal is what? Grams. So my first fraction, I'm looking for what? Moles. So it's on top. And what's on the bottom? Okay, can you tell me what conversion factor goes here? Beautiful. And where does his number go? Good, because it's molecules at the bottom. 6.02 times 10 23rd molecules per 1 mole. Molecules now cancel out. Times my last fraction, I'm looking for grams. And what's at the bottom? Okay, what is grams per mole? Molar mass of who? NH3. So N on the periodic table is 14 plus? Perfect. So 17 what? Grams over 1 mole. So what is my final answer?
Wait, actually, should I just take my number? Stop me.
11.578.
Oh, I was close to that random answer I made. 11 point. You guys all got that?
What was the original thing?
Sig figs.
Good. So again, this one, yes, this one sig figs matter. How many sig figs should my answer have? 2. Why?
Because that's the least amount.
Mm-hmm. Where's the second sig fig?
5.
Huh?
Oh, wait, 1.
Can 5 round 1?
Yes.
So my answer is
12.
12 what?
Grams.
Of who?
NH3.
Beautiful.
Oh, your thing already has the times.
Mm-hmm. Does that make sense how I got that?
Yeah.
Okay. So next one. No, these ones. Well, did you round the masses? Like you put.
I think at 70. Yeah, I got 11.578.
Did I just write it wrong? What did you get, Jess?
11.587. I got 11.
Okay, she's gonna do it right quick. Maybe. 11.587 or 78? Okay, so I just wrote it wrong. Sorry.
I'm not crazy. A little work.
My assistant here is lacking. Okay, 7, 8. Yes, sorry. So this one, sig figs matter, rounding matters. Number 2 and number 3 are the same exact thing with the map. Do you want me to do them?
No.
Promise? Even if one person wants, I'll do it.
Wait, say that again.
If you want me to do 2 or 3.
Wait, ask the question again.
If you want me to do 2 or 3.
The last one and see.
Or any of these.
The 3.
You want me to do 3?
Which one requires more steps?
2 is more steps.
Yeah, then do 2. So we can have everything.
So you want me to do 2?
Yeah, do 2.
Okay. So I have, it says, wait, you ready? How many formula units are in 18.3 grams of NaNO3?
Start at
Yeah, so what am I looking for? Okay, and that tells me that what's with my substance if he's a formula unit. He's ionic. Good. That's just to know. And I am looking for formula units, but I'm given grams. How many? Grams of who? Okay, so I am at grams and I am looking for formula units. I am at grams and I am looking for. So how many steps? Where am I going first? So that will go on. Okay, and what goes at the bottom? Grams per mole? What is grams per mole? Okay, so molar mass of who I need? Good. Na is 23 plus N plus. Good, and that gives me 37 plus 85 grams per. Okay, so where does that 85 go in my fraction? 85 grams per mole. Times my last fraction. What's on top? Formula units. Looking for formula units. And what goes on the bottom? Huh? Grams just canceled out. Now I have to cancel out my moles, formula units over moles. What number am I putting there? And where do I put his number?
At the top.
For formula units, I put it at the top, right? And then it's per 1 mole. Now when I do the math there,
1.296 times 10 to the 23rd.
perfect. 0.296. Good job. Times 10 to the 23rd. And my unit is of. Okay. How many sig figs should this have?
2.
There's 3 sig figs here, 2 here, and 3 here. We don't care about the ones. How many?
2.
Where's the second?
2.
Can 9 round 2?
Yes.
My final answer should be?
1.3 times 10 to the 23rd.
Nice. Some of you guys forgot to put like the times 10, 23rd on your quiz and stuff. I don't know how. 2 sig figs is the lowest amount. It's 2. 85 we use as the molar mass. Right there. Okay, and then 3 I can skip, right? Okay.
I learned how to do the reactive thing.
Show me after. Still 10. 10, 11, we're almost there. Look, this is 11. Okay, you ready? So on chapter 10, we're now talking about empirical and molecular formulas. What is the definition of an empirical formula?
Reduce to the lowest ratio. Whole number.
Good. And molecular?
Just the exact.
Good. They don't have to be reduced. No, just to know.
Worst part.
Okay? To find my empirical. All of this is steps to find the empirical. I'm not going to read it out loud. I'm just going to do it with you. Yes. Okay? I'm not going to just read it because it's going to make no sense. I'm going to do it and then read it as we go. You ready? Yeah. Okay. So, are you ready?
No, wait. Sorry.
It's okay. Tell me when.
Please. Just give me a break.
Show the exact number of atoms and they don't have to be reduced.
Empirical is
So we're going to do 2 examples. It says, find the empirical formula for a compound containing 12.16% that, blah, blah, that, blah, blah, blah. Okay? 1. 1 empirical, 1 molecular, 1% comp. Okay? So, if we are given percent compositions, are these percent compositions? Yes, percent of the element. What do we have to do? Good. So I'm going to take those 3 elements and I'm going to rewrite them as the same numbers, but instead of percent, I put grams. And this is the same exact number that we've already used like 100 times in a bunch of different examples. We've seen this one already 1,000,000 times. But it's the same steps and it has the extra step, which I like, so we're just going to do it. Okay? And what is the goal of an empirical formula? We are trying to look for yes, good. Moles of of the compound, the subscripts, basically. We call them moles, right? We're looking for these numbers. How many of each I have? I'm given in grams. These are what, again? How can I say them? Moles. So I will change these grams to, and so if I'm looking for moles, it will go on top. Okay? And how about the bottom? For all of them, correct? Grams in the bottom for all of them. Okay, what's the molar mass of carbon? 12 grams per 1 mole. Hydrogen is just 1, okay? And oxygen is just 16 grams per mole. The first one I believe is like what's 12.16 divided by 12? 0.1 what? 3. And then 10.81 divided by 16. It's like point.
6.756.
Perfect.
Yeah.
Right? Does it make sense to have C 1.1013, H 2.026? Does it make sense to have those numbers as my subscripts? No, we don't have decimals as subscripts. Also, it needs to be reduced to the lowest ratio. So I have to do what? Divide by the smallest number to make it at the lowest reduced ratio to 1. So what should I divide by? So divide by 0.6756. Okay, divide by that. Obviously, divide 0.6756 divided by itself will give me 1. 2.027 divided by that will give me 3. It should be like 3.00 something.
Yeah, 3.00.
So that's just 3. I don't have to worry about that. Okay, and then 1.013 times divided by that gives me 1.5. I cannot round these numbers. Cannot.
You gotta multiply it by 2.
Good. So this is still incorrect because I have a decimal. I need a whole number. So I will multiply whatever decimals I have by a whole number to make it whole. So start from the bottom. Can I multiply it by 1? No. Can I multiply by 2? Yes. It will make me have a whole number of 3. But if I multiply that guy by 2, I have to multiply everyone by 2. Does that make sense? So my answer is C3H6O2. Oh, yeah. Does that make sense how I got that? Okay, 2 says, what is the molecular formula for number 1 if the molar mass is 222 grams per mole? So it's asking for the molecular formula of number 1. What was the empirical for number 1?
C3H6O2.
Good. So again, in order to find molecular, you need a empirical. Okay, and it's giving us the molecular what? Mass, which is 222 grams per mole. The formula for this is you take the molecular formula, molar mass, and divide it by empirical formula, molar mass. You're with me? What's the molecular one again? It's given to me in the problem. You're with me? How do I get the empirical molar mass? This guy molar mass. Right, I'll add them all up. 12 times 3 plus 6 plus 16 times 2. Everyone understanding where I'm getting these numbers from? No?
Yes. Oh.
Remember, carbon is weighing 12. There's 3 of them. Hydrogen is 1, is 6 of them. I just put 1 times 6. Oxygen weighs 16, but there's 2 of them. Final answer is 74 grams per mole. So the molar mass of my empirical is 74 grams per mole. What is this divided? 3. You're with me, guys? I will take this 3 and then multiply. Take my empirical that I found, multiply all of the elements by 3. Right? Okay, what is 3 times the 3? C9, H18, O6. So there's my final answer. Does that make sense how I got that? Okay. This is the molecular formula. Good? Am I doing good on time? Okay, I have 30 minutes. Okay. Yeah, we have 30. It runs at 4:30. I could stay longer than 4:30, but I know some of you have to leave soon, so I'm trying to speed it up. Okay, ready? Percent comp. You want me to do this one, or are you guys comfortable? So remember, just to recap, percent composition is you got to find the percent of every element in the formula. So mass of each individual element divided by the total mass of the compound. Do you remember this?
Yeah.
Okay, let's find the molar mass of each element. N weighs how much? 14, but how many are there? So 14 times 3 gives me? 42? Okay. H weighs how much? How many H's are there? 9. 9 times how much is the weight? Okay, and that's just 9. P weighs? Perfect. And there's only one of them, right? Okay, and then oxygen weighs 16, but there's 4 of them, so 64. Add all of these up together, and what does that give me?
What the heck? I got 2,000. What are we finding? Why?
The mass of each element, and then now we're finding the mass of the compound by adding them all together. Point? 145.97? Thank you. Grams per mole. Do you guys see how I found each individual mass of each element and then added them together to get the total? To find the percent, I take each mass divided by the total and times by 100. Does that make sense? So I will take 42 divide by 145.97. Take 9 divide by. Take this one divide by the. You get what I'm saying? And then you would multiply everything by. Okay, and then that's how you'd get your percent comp. And then remember, we round to how many sig figs?
3.
So we'll do the calculation for this at the end if I have time. I just kind of want to get to stoichiometry because that's what everyone's having trouble with. You're with me? Because there's only one question of this on the exam. I can continue?
Yes.
Okay. All right, everyone's favorite part. Stoichiometry. So remember, what did mole conversions say? Conversions between? Of? Okay, and what does it say for stoichiometry? Yes, grams and moles only of different substances. So because if I have different substances, I must use a to solve the problem. Substance 1 will always be the given. Substance 2 will always be what I'm looking for. Okay, sig figs do not matter for this one. And with stoichiometry questions, you will always get one number. With limiting and excess reactant problems, you'll get more than one number. Okay? So, let's take a look over here. How many moles of CaNO3 are required to produce 33 grams, 0.6 grams of NaNO3? I'm given the reaction. I gotta make sure it's what first before I use the reaction? Balanced. Is it balanced? No. How can I balance this? Everyone agree? 3 CAs, 3 CAs. Wait, hold on. This should have a 2 over here. Okay. How many NO3s do I have now?
6.
Huh? 6. I erased it, sorry. 6. 3 times 2 is 6. So how can I fix that on the other side? 6. How many NAs do I have now? 6 on the right, and here I have 3. So I should put a what? Is everything balanced? Okay. So what is the question giving us for number 1?
Grams.
How many grams? 33.6 grams of who? Times a fraction all the time. The substance I start with, what number is he?
Substance 1.
Good. So I'm given what of substance 1?
Grams.
And I'm looking for moles of a completely different substance. Okay, so grams of substance 1 is right here. And I'm looking for what again? Moles of how many steps? Okay, So where should I go first? What am I looking for first? Moles of who? So moles of substance 1's on top, and the bottom is grams of substance 1. This cancels. Moles per gram, gram per mole of the same substance. What is that called? What is the molar mass of NaNO3? We already found that, actually, in a previous problem. NaNO3. NaNO3 molar mass, what was it? Okay, so it's 85 grams per mole. Where does the 85 go? Grams per 1 mole. Okay, you're with me? Times my next fraction. So I just found moles of substance 1. I'm looking for? Yeah, that's what the question's asking. For moles of substance 2, right there. So times my next fraction. Now I can put moles of substance 2. Moles of substance 2 is CaNO3 2. Moles of CaNO3 2. And what goes at the bottom? Okay, and when I have moles over moles of this different substance, and where can I get those numbers from? Good. How many moles of CaNO3 do I have? Right here. The coefficient is what you're writing there. 3. And then NaNO3? Right. 6. The number that's in front is what you write. Okay, now I solve it. What do I get? No question asking for moles of CaNO3 too. If it was, you do another step. Let me see.
Wait, you got it.
I want to see if you got it. Did everyone get it?
Yeah.
Isn't it? My limiting reactant is easier because it's less trying.
Did everyone get this as an answer? Everyone knows how to plug this into their calculator. I got 33.6 times 3 divided by 85 times 6. So I would do this first. And this is the answer, yes or no?
That's just times point.
No one got anything different? Anyone confused on how I did this? And do sig figs matter for stoichiometry? No. Okay. Should I do another one?
What you mean? No.
Just do from grams.
Or you want me to get to the limiting and excess? Okay. So these two you can do at home on your own in practice. Okay. Limiting and excess. So remember, just to recap on the limiting and excess. Remember that bicycle problem I gave you? I'm gonna say it again because I feel like it really helped some kids. So real quick, I know I have 25 minutes left. To make a bicycle, I need 1 frame, 2 wheels, 1 seat, 1 handlebar. That creates 1 full bike. Okay? The question here asks, how many full bicycles can I make with 4 frames, 11 wheels, 6 seats, and 5 bars? Well, let's see how many bikes you can make for each individual item. With 4 frames, how many bikes can I make? With 11 wheels, how many bikes can I make?
5.
Each bike is 2 wheels. How many can I make? Full bikes, 5. With 1 extra wheel left over, right? Okay, you're listening, guys? How many bikes can I make with 6 seats? And how many bikes can I make with 5 handlebars? Okay, so if I have all of these parts, what is the most amount of bikes I can make? 4. Why?
4 frames on the
If I run out of frames, can I make any more bikes? The substance that runs out first is called the limiting. And who is our limiting? The frames. Okay? Applies to reactions. When I run out of a material first, a reactant first, is called my limiting. If I have any extra of it, we call that excess. So, this right here is like a description on how to find the limiting and excess reactant. Okay? I'm going to do an example in a second, but this is like basically a really good description on how to find it. Okay? Percent yield ties into this. percent yield, we're given the actual over the theoretical. Actual will always be given to you in the problem. Yes? Yes or no?
Yeah.
Always given. And to find the theoretical, you must use the limiting reactant to find it. Yes. Okay? So you guys can read all of this on your own. I think it's very helpful if you read it. It kind of just breaks everything down. Now we're going to jump straight to a question. Okay? You ready? This is how your exam is. So your exam, I will give you one reaction, 4 parts.
Will you give us a fake balance reaction?
I will give you one full good balanced reaction, and then I will give you another one, but only the words. Do you see that?
Yeah.
Okay.
That would be a crazy one.
So, let's look at this one together. It says, if 100 grams of calcium phosphate react with 25 grams of iron 3 chloride, how much calcium chloride can be produced? First of all, how many numbers do you see here? 2 numbers. So off the bat, I want to analyze those numbers. Okay, wait, what kind of numbers are they? In A, how many numbers do you see? Okay, off the bat, I'm not going to jump to conclusions. I'm going to figure out who these numbers belong to. 100 grams belong to who?
Calcium phosphate.
Do you see calcium phosphate in the reaction? The first one, right here, 100 grams of that. Yes? And the second number? 25 grams of?
The other reaction.
Okay, other reactant. Do you see how it gives me 2 gram amounts of my reactants? Automatic limiting reactant problem. However, let's say that this number was actually a product number. Now I'm just dealing with stoichiometry. Just now I'm using this number. I use the only number it gives me, and I look for how much product is being made. Okay, so that's how you determine if you're doing limiting or excess reactant. You see if it's giving you amounts of reactants. If it gives you 2 numbers for the reactant, you're going to be doing limiting and excess reactant. If it doesn't do that for you, just do classic stoichiometry and do what it's asking you to do with the number it gives you. So, 100 grams of calcium phosphate reacts with 25 grams of iron 3 chloride, right here. How much calcium chloride can be produced? Okay? I am looking for how much product can be made. Where's my product? Do you see him? What's the formula for my product? How much product can be made, guys? How much calcium chloride can be made? Where's the formula for calcium chloride in the reaction? CaCl2. Okay? So we are trying to figure out how much product. You're with me? And this will always be in grams. Your answer choices will be in grams. You're with me? You're with me? How do I know which number to use to get how much product I can find? This is why I need to use the limiting excess. Okay? If it only gave me this number, then what do? I just use that number to find how much product. Does that make sense? But it doesn't. It gives me 2 numbers. So then I have to figure something out. Is my reaction balanced? Yes, it is. Let's read it in terms of moles. What is this if there's no number? 1 mole of this reacts with 2 moles of that to produce 3 moles and 2 moles. Bye. How many moles of this is required for the reaction? According to the reaction. How many moles of this is required? 1 mole is required. How many moles of this is required? I'm asking for moles. I'm not asking for grams. Okay. Yes, you're right. Look at this. Look at me.
Yes, I'm here, Miss A.
100 grams of this and 25 grams of that is how much I have weighed out sitting on my lab desk.
Okay.
The reaction, the balanced reaction tells me I require a mole of that and 2 moles of that to make product.
Yes.
But I have grams.
Yes.
So let's compare my grams to
Oh, yeah,
moles.
try to make them go-
Yes. So I will take 100 grams of my product, of my reactant, and I will change them to grams, to moles. Same thing with 25. I will convert to moles. You're with me? And grams at the bottom, right? Okay, the molar mass of Ca3PO42. That's a big one. Ca3. Do 40.08 times 3. What does that give you? Then add the rest. I don't know.
I'm gonna tell you using my calculator.
Thank you. Did everyone get that? 310 point?
What's P?
P, yeah, 30.07. 97, yes. Yeah, huh? Times 2. Plus 16 times 8. What is that? That's the final. I want the molar mass. 310 point
18.
grams per mole.
Sorry.
You're with me?
Yeah.
And what's the molar mass of FeCl3? 55.85 plus 70.9 plus 35.45, please.
Oh, should I just do it?
55.85 plus 70.9 plus 35.45.
Oh, wait, what an iron now?
Wait.
She added up the first two.
Thank you.
Oh, for C. Okay. I'm thinking.
Because I automatically know that 2 CLs is 70.9 because it's in my head forever. So what is the answer? 162. Everyone got that? Okay. So how many moles of whatever do I have? Ca3 whatever do I have? How many? What is that? Oh, that's for the 25 grams? Guys, divide this for me, please. We're low on time, and I haven't even started the problem yet. This is just limiting.
0.223.
Huh?
0.3223. No, 3. Oh, wait. 3.
What?
0.09.
3223. Yes? Okay. 0.154. There's no more numbers.
No, 413.
The second one.
Like that.
Yeah.
That's good? Okay.
No, I did.
Now, I want to set this to a ratio equal to 1 to make it easier for me to compare. So I divide by, who's the smallest? They're already in order. So just divide them. Okay, what moles is the top? Who's the top? Good. Ca3, blah, blah, blah. And who's the bottom? Fe, blah, blah, blah. Okay, moles of both. Moles of who? Goes on top. Right? Over. Always over 1. Mole of? Beautiful. Okay, now let's compare these numbers to my reaction. So wait. I'm going to erase the grams for 1 second. Again, how many moles of Ca3 did we just get? 2.148. And how many moles of FeCl3 did I just get? 1. You're with me? In the reaction, how much do I need? He tells me what I need of Ca. 1 mole of Ca. How many do I have?
2.
So I have enough or I don't have enough? I have more than, I have what? Okay, keep that in mind. How many FeCl3 do I need? But how many do I have? I don't have enough, so therefore, my limiting and this one is my? Perfect. I don't use these numbers in the reaction. How much of my limiting did I start with in the problem? Wait. Yes, but wait, how many grams? Good. So I took the 25 and changed it to? So this is the number that I use for all of the work, all of the problems. Okay, the question is asking me for what? How much what? How much calcium chloride can be produced? And what is my given then? 154. Yes, my limiting is always my given when I do these types of problems. Moles of FeCl3. You're with me?
Yeah.
Okay, and I'm looking for, what does the question ask? Calcium chloride can be produced. And I said grams of that, correct? How much what? Grams. So now I'm doing moles of FeCl3 to grams of CaCl2. Those are two different substances, yes? Where can I find the map to solve for this? All the way up here. Right there. I am given, again, moles of substance 1, and I am looking for grams of substance 2. You're with me? Okay, so I will do that now. Moles of FeCl3 at the bottom because I'm canceling it out, right? And I want moles of substance 2.
Oh, you're looking for moles?
Yes, mole ratio. I'm looking for grams of substance 2 is my final answer. 3 over 2, correct. Times my last fraction, grams of substance 2. Okay, moles of substance 2 goes to the bottom. I'm canceling it out. Grams of substance 2 on top. Grams per mole of the same substance. Okay, 70.9 plus 40.08 will give me 110.98 grams per mole. Okay, then I will just do the math. That times 3 times 0.1541 divided by 2 at the bottom gives me 25.653 what?
Grams of CaCl2.
My substance 2. The question is asking me this number. That's how much product I can make. My actual or my theoretical?
Theoretical.
My theoretical will always be the amount I have to calculate. Keep in mind. Okay? Now, I'm going to skip to D for a second. It says if 15.89 grams of calcium chloride is experimentally made, what is my yield? So it literally says experimentally made. So what does that number mean? The actual. So now I have my actual, which is what again?
15.89.
And I have to divide that by my, which is
25.65
times
100.
perfect. Remember, this is the percent yield formula, which is
Actual.
yes, which is actual over theoretical times 100. You guys understand what I'm doing there, right? Okay, and this will give me what? Tell me again. Is that a good yield? No. That's not a good yield. Yeah, 61.9%. But just because it's a bad yield, does that mean it's a wrong number? No. This is the correct answer. There is my yield. Do you see how I got that? Okay, question B says, what is my limiting reactant and excess reactant? We already found that. What's my limiting?
FeCl2.
And what's my excess?
Ca3 parentheses PO4.
Perfect. I don't know what number that is. Okay, almost done. And then my final question says, how much excess reactant is used and left over in the reaction? Hold on. Who is my excess?
Let's see.
Who is my excess again?
Can you go up? Tap on the board.
Just right there. Good. Excess is who? Ca3PO4 2. It wants to know how much is used. In order for me to determine that, again, who am I using? What is the number that I use for my given? Always. My limiting. And who is that? What is that? How much is that? Okay. 0.1541 moles of FeCl is my limiting. Does everyone agree? So I will then use this number to see how much excess is needed. Proportion, right? If I have this much FeCl reactant, how much of the other reactant do I need to make ratio product? So I'm looking for how much is used. If I solve this to find grams of my excess, that will be how much I used. Always in grams. 1 second. Always in grams. So follow my map. Moles of FeCl3 is my limiting, and I am looking for grams of Ca3, whatever, my excess. How much I used. Okay? So if I started off with 1 frame, how many handlebars do I need to make a bike with 1 frame? 1. It's a ratio. So if I have this many moles of FeCl3, how many grams of the other reactant do I need to make my product. So moles of FeCl3 at the bottom and moles of my excess will go on top. You're with me? This is what is this called? Okay, and then what number goes on the top?
1.
Oh, I was right.
1/2.
Yes, 1/2 times my last fraction. Right, so moles go at the bottom, I'm canceling it out, and I'm looking for grams, so that goes on top of that substance. I'm not going to rewrite it, it's too many words. Too many numbers. What is the molar mass of Ca3PO43? We already found it up here. Molar mass. 310.18 grams per mole. So now I took my limiting, and I'm looking for my excess. Okay? So how much excess I used. So then I will just do the math.
About 23.89.
I also got 23.89. Or we'll just round that? No.
Can I?
We'll round it to 9. 23.9.
I usually just leave all of it.
Grams of who? Wait. Grams of who did I just find? Okay, this is so important. We just found how much was used. Used. To find out what was left over, you need to see how much you started with. How much Ca3PO4 did I start with?
100.
Do you see that? I started with 100 grams. Start. Subtract by my used, which was 23.9. Gives me my,
76.1.
which is what is that? Leftover. 70
6.1.
grams, whatever. So if I ask for used, the one straight from the reaction. If it asks for leftover, how much you started minus what you got will give you the leftover. Does that make sense? Okay.
Can you start passing out the assignment?
Yeah. Huh?
We have 4 minutes left.
Passing out what?
The assignment thing.
Oh, yeah. Please write your name and your period so you can get extra credit. Let me tell you what to put on the cheat sheet. All right, ready? Now what you actually came here for, yes? All right.
You're gonna write it all the.
I'm not going to, I'm not going to make it for you and send it to you, but I can write it out, yes. Okay, so here, I have a great idea, actually. I'm such a smart person. So what I'm going to do is I'm going to make a new document, and I'm going to put the review next to it like that. Okay, and I think that you're able to see both of them if I do this. Okay, I'm going to copy and paste everything from this that you need in your cheat sheet. Ready? Okay. So, first thing that I think you should need in your cheat sheet, the first 2 questions off that exam are the definitions for binary and oxy acids. Okay, that's the first thing. Binary and oxy acids. Okay. Next thing that I think you should include is, I'm sending only the notes.
You're not sending a cheat sheet.
Can I just take a picture of what you said?
Okay? I don't want you to take my cheat sheet and just print it. That defeats the purpose, you know what I mean? Okay. So that's the first 2 questions. Now, the next questions are by how to name acids. So I highly suggest that you take the rules of the binary and oxy acid naming, you include some examples in there, and you just paste that right in to your document. Okay? The rules, how to name them. Okay? Next, the rules for naming bases. Also suggest that you take that and some examples. Okay? You take that and some examples and you put that right in the document also. How to name bases. You're with me? Okay. So far so good? Next, what I suggest you include literally all types of the reactions. If you can squeeze exactly what I wrote here, I think that would be very beneficial for you. But don't put every, you don't have to put every single example I did or every single like note I did. Yeah. You can put whatever on that sheet as long as it's not you got A, B, C, D from somebody, which is not possible. Yes.
Print one set of like the cheat sheet and the other side you write down, but like I'm gonna connect 2 pages, but they're gonna be.
Ask me in a second. 1 second. Okay? All types of reactions should be included in your cheat sheet. You ready? Next. Okay? Well, you have a solubility table. Next, I'm giving you a secret. Right here. Put somewhere. All solid, no, sorry. Metal oxides are solid. Another thing you should write, Brinkelhoff, and what they are. So bromine is a liquid, iodine's a solid, nitrogen gas, chlorine. Is Cl2 a gas?
Chlorine gas?
Yes, chlorine is a gas, hydrogen's a gas, oxygen's a gas, and fluorine's a gas. I asked you one of these. I don't know which one. I don't know. I don't know which one. I don't really know which one I asked you. I don't really know which one I asked. Okay? Next. Then what you want to include is the definition of solubility right here. Here's a question. Definition of solubility right there. Okay, I'm including that. Okay, right here. Put them right there. Definition of solubility. Bye. Okay. I also want to put this. This is also a multiple choice question here. Also a question, multiple choice. You're with me? I'm literally going through every single question. I'm letting you know right now. I'm looking at every single question. Okay? Then, what I will include is the exact definition for a spectator ion. That is also word for word verbatim on the test. On my cheat sheet, that's what I would put. The exact definition of a spectator ion right there. This exact definition is copy pasted straight from the exam. Okay, so I will put that here. Okay?
At the end, I can take a picture of that.
Sure.
What is this?
Yes. Okay? Then, what I would do is I would take the rules of complete ionic, or you know what I would do? I would just take an example. I would write one of the examples like this, and I would just put it in my thing. Okay, that's what I would do. I don't need to write out all of that extra stuff. I don't want to. I would probably just write one of these. I wouldn't even write both of them. And then you know what else I would do? I would also copy that red thing that I put right there with a star. You see it? You see it? Right here. You're with me? Okay. Okay? Then, I would also somewhere write Miss A's birthday. Okay? That's 6 points. Bonus question, just letting you know. Yes.
Good. Wait, how many points was the Jeopardy?
10.
Okay.
Okay? Then, so that's all of my... Oh, then I want to write the definition of complete ionic equation. Right here. Give me the exact one. This is the exact definition on the exam. Then I put the definition of complete ionic. Okay, I don't care about this part here. You're with me? Okay. Then, I want the definition of a precipitate. I don't have it here, I think. So I'll write precipitate. Definition. You can get that from the PowerPoint. What does precipitate mean, guys?
Solid.
Just means solid. Okay? Then what I would include is my grams to mole map right here, this beautiful map. I would put this exact map with the particles, duplicate, cut. I would put it right here. I would put the map. And obviously you organize this a lot better than I do, right? You title everything, whatever. And I'd probably put an example question in there. And I would also include my conversion factors. You're with me? So I'm going to copy paste my conversion factors right here, duplicate, cut. I would put that here too. Cool, you're with me? Okay. Then I would do 2 examples of I wouldn't even write how to do it. I would just put examples of empirical molecular. Just put those examples right in there. You know what to do, right? If you see the examples, you just follow the same steps, right? Okay? So then that's molecular, whatever, empirical, that's right there. I would also put an example of percent comp with the formula. So I would definitely put the formula for percent comp. Okay? I would put that there. Here too. Okay, I'll put that here too. Good. Next, what I would do in my cheat sheet is the stoichiometry map. Actually would be the first thing I ever write. Right here, stoichiometry map. That's going there. Okay, my stoichiometry. I'm also gonna even put an example. I would do a long example. I would do a gram to gram example. So find a gram to gram example and I would do that. I don't have one here, we didn't do it. So I would duplicate this, copy, and I would put an example of how to do the problem. Okay? There are 4 questions like that. Then, last but not least, for my limiting and excess, honestly, I would just, if you could fit this whole thing and read it and understand it, same with percent yield, you should be fine. If you don't want to do that, I would honestly just take the whole example and put it in there. Take the whole example, what we just did, put it in my sheet. Cut it down as much as you can, but to a point where you can actually understand it. And then, if you can understand the example where the numbers are coming from, then you could follow the same steps. Because, by the way, your exam is written like this. This is the exact part A. This is the exact part B. This is the exact part C. This is the exact part D. You know what I'm saying?
Can you scroll through the cheat sheet? Could you airdrop it to you?
Yeah, one second. Done?
I'm gonna record. Go.
Tell me to go?
Yeah.
I can go.
Yeah. Wait, not so fast. Not so fast.
Okay, girl. I put you on one job.
Okay, and if you want the document that we just went over, I can airdrop it to you right now. Have your airdrop on.